Welcome to True Projects. In this video, we are going to explain about the project that is Advancing Precision Medicine, VAE Enhanced Predictions of Pancreatic Cancer Patient Survival in Local Hospital. So, before getting into the execution, first let us understand what is the project about. So, pancreatic cancer is one of the most aggressive and deadly cancers because it is usually detected too late. And the pancreas, it is small organ, but it is crucial organ that is located behind the stomach. And it is responsible for producing digestive enzymes and regulating blood sugar through insulin. The most common type of pancreatic cancer is the pancreatic ductal adenocarcinoma, that is PDAC, that we call as pancreatic ductal adenocarcinoma, which makes up about 90% of the cases. And this cancer, it develops when the cells in the pancreas start mutating uncontrollably, leading to the formation of tumors. And the exact cause isn't always clear, but certain factors include increase the risk, including smoking, chronic pancreatitis, that is long-term inflammation of the pancreas, diabetes, obesity, and genetic history. The biggest challenge with pancreatic cancer is that it doesn't show the obvious symptoms in early stages, but by the time symptoms like persistent abdominal pain, jaundice like yellowing of the skin and eyes, and unexplained weight loss appear, the cancer has often spread to the other organs, making treatment much harder. So, because of this, pancreatic cancer is one of the most difficult cancers to treat. Early detection is extremely important, but current screening methods are not very effective. This is why researchers are constantly looking for better ways to diagnose it early and improve treatment options. And one of the biggest challenges, that is one of the biggest problems with pancreatic cancer, is that it is extremely hard to catch early. Right now, doctors rely on methods like CT scans, MRIs, and biopsies to diagnose it. But these come with a lot of issues. They are expensive, invasive, and not always reliable, especially in the early stages. By the time pancreatic cancer is confirmed, it is often too late for effective treatment. And here, the other major issue is that its symptoms are vague and easily mistaken for other common conditions like acid reflux, gallbladder problems, or even general general digestive issues. So because of this, people often get misdiagnosed or go undiagnosed for too long. This delay in detection means fewer treatment options and worse survival chances. What really needed is better way to detect pancreatic cancer early, something that is accurate, non-invasive, and affordable. If doctors couldn't identify it sooner, patients would have much better chance of getting effective treatment and improving their survival rates. So to overcome with all these issues, this project focuses on using machine learning to accurately detect pancreatic cancer at an early stage using urinary biomarker data. Instead of relying on traditional invasive diagnostic methods, this approach uses biological markers found in the urine to classify whether a person has pancreatic cancer. And this classification system is designed to place patients into one of the three categories, that is no pancreatic cancer, meaning patient has no pancreatic cancer, and benign is a condition where indicating a non-cancerous condition related to pancreas, and presence of pancreatic cancer, that patient is affected with this cancer. And to select the important features, we have incorporated VAE, that is variational autoencoder technique, to select the most important features. And that features are trained on these machine learning models. So to ensure high accuracy, multiple machine learning models are used, including decision tree, support vector machine, and advanced ensemble learning techniques. So these models work together to analyze the biomarker data and classify patients effectively, which helps doctors to make informed decisions about further diagnosis and treatment. And to make sure that system is reliable and accurate, all the models are evaluated using this key metrics, that are accuracy, precision, recall, and FN score. So these are the metrics used to evaluate all the classification models. And by evaluating the model with these metrics, it ensures the predictions are not just random cases but trustworthy and clinically useful. So this non-invasive and data-driven approach can help doctors detect pancreatic cancer earlier and make better treatment decisions, potentially improving patient outcomes significantly. And here, to further improve the performance as an extension, we are incorporating an extension model that is voting classifier. So instead of relying on a single machine learning model, this method combines the predictions of multiple individual models. Each model has its strengths and weaknesses. So by taking a collective decision, the system produces a more balanced and accurate final prediction. And this helps to reduce errors and also improve overall classification performance. And in addition, to enhance the prediction process, a user-friendly frontend is developed using Flask framework. So this allows users to interact with the system easily, making it a practical tool. Since the data is involved is sensitive information, user authentication is implemented to ensure that only authorized users can access the system. This guarantees security and also privacy, making the tool more reliable for medical use. And moving on to the implementation of the project, to implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the necessary libraries and dependencies required for data processing, visualization, machine learning, and Flask framework are imported. And then exploring the data set. So here, the dataset containing urinary biomarker information is examined to understand its structure, missing values, and all the other data to understand its structure. So here we will be examining the dataset. And also we will check for all the different classes in the dataset, that is no cancer cases, benign cases, and malignant cases. Coming to data processing, here the dataset is cleaned and formatted, including handling missing values, normalizing feature values, and preparing it for further analysis. Data visualization. So, various graphs and plots are generated to analyze trends, feature distributions, and class imbalances within the dataset. Then comes selecting X and Y. So, here the independent variables that are features are chosen as X, while the target variable, that is classification label, is assigned to Y. And here the dataset have imbalanced classes. So, here synthetic minority oversampling technique, that is SMOT, is applied to generate synthetic samples and balance the dataset. And we have selected features. So here we have selected features using variational autoencoder. So all the models will be trained on all the features first and also on the features selected using variational autoencoder. Then comes splitting the data set. So here the data set is divided into two subsets. One is training and the other one is testing. Training set is used to train the model and testing set is used to evaluate the model. Coming to building the model. So here in this step, machine learning models that are decision tree, support vector machine, etc. are implemented. I mean, they are defined for classification. Then comes training and building the model. So here the models are trained using process dataset, learning patterns and relationship between features and the target variables. And here in the step, all the accuracy, I mean all the models are evaluated using accuracy, precision, recall, and FN score. And coming to the part of front end, so a user-friendly web interface is built using Flask enabled front end. So Flask framework has been used for building user-friendly web interface, and user registration login functionality are implemented using SQLite database to ensure secure access. And in the front end, users will be able to give input feature values that will be pre-processed at the backend. It will be fed to the trained model, and finally outcome will be displayed through the front end of the application. So this is how you need to implement the project. Now moving on to the algorithms used. So these are the algorithms used in this project. This is the extension model, and these are the other models that are used for classifying the pancreatic cancer. And now coming to the requirements to implement, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 25 GB. And software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute the project, we are supposed to open the code folder that contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. So in this folder, we have the data set that is used in the project. So let's open it. So this is the data set. So this is the data set that is used in this project for training the models. And now let's close this. And here in this case, we have, I mean, here in this file, we have explanations for all the feature values, all the attributes. Let's close this. And in this model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files. They will be loaded into the project code during runtime of the application. And here in the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. Coming to templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the sample file in which we have test cases that we will be using in the front end for predicting the cancer, that is pancreatic cancer. This is the signup.db file. This file is a database file which is used to store the user information. So now copy the path of the code folder from the address bar of the file explorer. I've copied it. Now open Anaconda prompt. It is open. Give the command cd, give the space and paste the copied path. Now click on enter. Here you can observe right current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So copy this local link provided by the Flask framework and paste it into any web browser. I copied it. I prefer Google Chrome, so I will paste it in that. So I'll paste it in the Chrome. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are signing up newly. I have already signed up. I'll directly sign in. So click on sign in and give your username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? So these are the parameters need to be given as the input. Based on these only, pancreatic cancer will be predicted. So let's understand each of them. How will they be used in this project? The first one is patient cohort. That is the category or the group of the patients belong to such as healthy individuals, those with benign conditions or those diagnosed with pancreatic cancer. Then comes sample origin. So it is the biological source of the sample such as urine or the blood used for biomarker analysis. Then comes age. It is the patient's age as pancreatic cancer risk increases with the age. Then we have sex, that is the gender of the patient, whether a person is male or female, as some conditions may have different prevalence related to based on the sex. Then we have plasma CA19, that is carbohydrate antigen 19-9. So it is commonly used blood biomarker for detecting pancreatic cancer, though it is not always specific. Then we have creatinine. So it is a waste product from muscle metabolism measured in blood or urine, often used as to assess the kidney function, which may be affected in the cancer patients. Then we have LYVE1. So this LYVE refers to lymphatic vessel endothelial hyaluronan receptor 1. It's a biomarker that helps in indicating pancreatic cancer through urinary samples. Then we have REG1B. So it is regenerating family member 1 beta. It's a protein linked to pancreatic diseases and used as urinary biomarker for cancer detection. Then we have TFF1. So it is the terrifoil factor 1. It's a protein involved in mucosal protection found in urine and associated with pancreatic cancer. Then we have REG1A, that is regenerating family member 1 alpha. So it is another urinary biomarker that indicate pancreatic cancer presence. So this is all about the parameters. Now let's give the input. For that, let's open the sample case. So let's apply filter to the last variable, that is the target variable that we are supposed to predict. Let's apply filter to class 0. So let's enter these values. So here patient cohort value is 2 and Sample origin is PPTB and the age is 50 and the gender is male. Plasma CA19 is 654.002943 and then creatinine value is 1.31196. And then we have LYVE value that is 0.874513. And we have REGB1 that is 21.96 and TFF1 is 199.71 and the last one is REG1A that is 735. Now let's click on predict. And here the given input, it will be pre-processed at the backend and then it will be fed to the train model. Train model, it will be giving us the prediction, predicting whether the person has pancreatic cancer or not. So just wait for a while. Here we got the prediction. So we got the prediction that the prediction indicates that patient does not have any pancreatic disease. So here with the given input, the application, the model is predicting that patient has no pancreatic disease. Now let's check with the other case. So now let's check with this case. So give the patient cohort value as 1, sample origin is PPTB and the age is 56, gender is male and plasma CA19 is 654.002943 and creatinine is 1.39113 and then LYBE is 2.93 sorry 984651 and let's copy this REG1 value, paste it and then TFF1 is 269 and with decimal points and the last one is REG1A. Now click on predict. It's being processed at the backend. And here we got the prediction that the prediction indicates that patient does not have any pancreatic cancer. So here we got the result that patient does not have any pancreatic cancer. Now let's check with the other case. So let's apply filter to class 1. And let's try with this case. So patient COHRT is 1 and sample origin is LIV, age is 39, gender is female and plasma is 12, creatinine is 0.18096 and LYVE1 is 4.440416. And then we have REG1B that is 29.6. Then we have TFF1 that is 431. REG1A. So paste it here and now click on predict. So here we got the prediction that patient is predicted to have benign hepatobiliary disease. It is benign hepatobiliary disease. So this indicates, the prediction indicates that the patient has benign hepatobiliary disease, meaning a non-cancerous condition affecting the liver, gallbladder or bile ducts. While this is not a pancreatic cancer, further medical evaluation may be needed to confirm the exact condition and determine the appropriate next steps. So this is not the pancreatic cancer, but it is some other disease. Let's check with some other case. So now let's check with this case where patient cohort value is 1 and sample origin is UCL and age is 67, gender is male and plasma CA value is 654 and then creatinine value is 2.57 and the next one LYVE1 is 4.02 and the next one is REG1B. Then we have 830 as TFF1 The last one is 236, that is REG1A. Now click on predict. So here also we got the same prediction that patient is predicted to have benign hepatobiliary disease. That means he has no pancreatic cancer but the other disease. Let's check with one more class. So apply filter to class 0, class 2. Now let's check with this case where patient cohort is 1, sample origin is ESP, and age is 70, gender is male, and the next one is plasma CA19, that is 654, creatinine is 0.78, LYVE is 7.85, and the next one is, that is REG1B, it is 34, and the next we have TFE1. So copy it, paste it, REG1A, and now click on predict. So here we got the prediction that patient is predicted to have pancreatic ductal adenocarcinoma. So by the given values here, the application is predicting that patient has this pancreatic cancer. Now let's check with the last case. So now let's check with this one where patient cohort is 2, BPTB, 70, female, and 654 is the plasma CA19, and the next one is creatinine, that is 0.610, LYV, that is 5.50, REGB, that is 17.621, and the next one is 167.049, and then we have 735 as the REG1. Now click on predict. So here we got the prediction that patient is predicted to have pancreatic ductal adenocarcinoma. So here also for this patient with the given values, the application is predicting that patient has pancreatic cancer, that is pancreatic ductal adenocarcinoma. So this is how you need to execute. Now let's check with the graphs. Click on graph. So here the first graph is the sample outcome graph. Here on x-axis we have diagnosis and on y-axis we have count. So 0 is one type of class, 1 is other type, and 2 is other type. So 2 refers to no pancreatic disease. Sorry, 0 refers to no pancreatic disease, and 2 refers to benign case, and 1 refers to presence of pancreatic case. So this shows the sample distribution. And this is the correlation matrix. And here we have all features. Graphs for all features. So here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained on all the features without doing any feature selection. So here we have precision score, recall score, and FN score. And here we have accuracy comparison graph. So here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained on the features extracted using variational autoencoder. And here we have precision score, recall score, FN score. Now click on sign out. In this way, just by giving values to the application will predict whether the patient has pancreatic cancer or not. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.